Hello, everyone, and welcome to another episode of Spotlight on Security Tech Insights. We have a very hearty topic that is all the rage right now. We're going to talk about considerations for AI innovation, planning, and security risk. We're also going to talk about considerations around tools, processes, analytics, security risk, and more. So I am here today joined by Craig Martell. He is our Chief Technology Officer here at Cohesity. And Craig has a very robust background. He was previously the Chief Digital and AI Officer for the DoD. He's also worked for notable organizations such as LinkedIn, Lyft, and Dropbox, leading all of their AI and ML initiatives. Craig, thank you for joining me. And what I'd like to start with is with this career, why did you choose Cohesity?
Thank you, Theresa, and thank you for having me. Cohesity has been on my radar for quite some time. I've known about Cohesity since Mohit founded it, and I've always found it a really fascinating. Always found his vision really fascinating. So he originally had said that they wanted to build a system that would allow us to do analytics on top of secondary data, analytics on top of backup data, and I always found that really motivating because if you think about how much time series data there is in your backups, you realize that you can ask some really robust questions about that about your business using that data. And it's also very consistent with the way I view what I call the AI hierarchy of needs. So, most folks think AI is the answer to super hard problems. You go buy a bunch of AI, your problems are you pay whatever amount of money you have to pay, and your problems are solved. But it's actually the opposite. The AI comes at the end and almost for free. I'll explain what I mean by that. The more important thing is that the lower layer of this hierarchy of needs, which is building out high quality data that's discoverable, accessible, and usable by analysts and model builders. And then there's a layer on top of that, which I call analytics and metrics. It's the ability to measure how successful you are at whatever you want to do with that data. And those two are prerequisites before you even remotely think about getting to AI, because no matter what AI technology you use today, all the hotness is large language models. But whatever AI technology you use, you're going to have really high quality, accessible data that is representative of your business and the way that you think about your business. And you're going to have the ability to measure the success of those models or techniques in the marketplace. So AI is very late in the hierarchy. Quality data is very early in the hierarchy, very low in the hierarchy. And Cohesity has spent the last 11 years doing exactly that, building out a layer of high quality data that we can now make accessible to AI solutions. But we wouldn't be able to. You can't just go buy an AI solution without the high quality data first. And so that's the main reason I'm motivated by Cohesity. They've been spending the last over a decade getting the data right, which I think is the most important part.
Yeah, I didn't mention this, but I've been at Cohesity for the last 5.5 years. And so it's nice to see that you recognize that work that we've been doing here for so long. So you talked a little bit about what AI is. You talked about the hierarchy of needs. I don't know if there's anything else you'd want to share there, but I'd love to hear more about that quality data layer as well. So what are your thoughts,
Well,
Chris?
yeah. So why don't we actually start with asking the question, what is AI?
Sure.
And I think it's when I ask that question in a public setting, I'll get a whole range of answers. But often of late, over the last, say, 2 or 3 years, I'll get answers like a thing that solves the hardest problems or a thing that thinks like humans. The very sort of science fiction level views of what AI is. But AI is much more pedestrian than that, much more pedestrian than that. It's simply statistics at scale. How does AI work? AI, when you want to build an AI model, you want to do it for a particular use case. By the way, this stuff is not monolithic. There's not one, I buy this solution and I've solved all my problems. It's use case by use case by use case. So you have a particular problem you want to solve. You want to use AI technologies. You gather a bunch of data from the past. Remember, I said it's statistics at scale. What is statistics? You gather data from the past and you use it to predict the future. That's extremely important to think about it. There's two pieces to that: gathering from the past and predicting from the future. The gathering from the past is the high quality data layer. You have to have that data that represents the past. And the more of the past you have, the better, because the more robust your prediction of the future will be. And the more varied scenarios you have in the past, the more your model will be able to handle varied scenarios in the future. So you need high quality, very large amounts of high quality, varied data about the past. Build a model using that data, and you use that to predict the future. Okay, so here's the really, and how do you know how well you're doing at predicting the future? Well, you need evaluation techniques. You need to be able to say, here's my goal, here's my business goal, here's a model trying to achieve that goal. Let's just pick a really simple one: spam detection.
Yeah.
You've got to determine whether an email coming in is spam or not. Well, how does it do that? Well, it looks at all of the things in the past that you've called spam and all of the things in the past that you've not called spam. It uses the words and other features in those emails to build a model. And then a new email comes in and it calls it spam or not spam. But you have to be able to evaluate how well it's doing at that. But here's the real trick. If you're going to use the past to predict the future has to look sufficiently like the past in order for that model to be effective. So you can think about it in the spam detection scenario where people try new tricks now. Now there are new tricks. They use different words. I remember for a while they were spelling Viagra with the at sign as opposed to the A. Well, that means the old model of just looking for words didn't work because they were using other ways to represent those words. So suddenly the future changed. Once the future changes, the model built on the past data isn't as effective. You have to remodel it, gather new data to be able to predict the new future. So AI is statistics at scale. You gather data from the past, you use that data to build a model, you use that model to predict the future. You need evaluation techniques to know how well you're doing at predicting the future. And when you say it that way, many people are unhappy with me because it's no longer magical. It's no longer, oh, I can't believe we've reached the age of, pick your favorite, sci-fi show. We've reached the age of sci-fi. We have thinking machines. We have things that can reason like humans. None of those things are true. We do not have thinking machines. We do not have artificial general intelligence. We do not have things that can think like, reason like humans. We have a whole collection of statistical techniques that use data from the past to predict the future. Sometimes they work, sometimes they don't.
Yeah, I really like that analysis. So I want to talk a little bit about the data layer because Cohesity does maintain a lot of data, but you said something about the spam control and the historical and the analytics. So in terms of how do you ensure the quality of that data? Like, how do false positives and negatives fit into that?
Yeah, so we should talk a little bit about the evaluation layer. So when you evaluate a model, there are a number of different ways to evaluate it. But if you're building a classifier, and a classifier is something that says this thing is A and this thing is B, you have two different kinds of errors you can have. You can have false positives, which are we'll continue to use the spam, where I say something. It's really weird because the positive here is I have detected spam, even though that's a negative to us experientially, right? Yeah. So the false positive, the false positive would be calling something that's not spam, spam. So I'm falsely calling it the positive thing. I'm falsely calling it spam. Mm-hmm. Okay. Well, it's really important to have a feedback loop to make sure that the model can continue to learn when it gets it wrong. So Theresa, what do you do when something that wasn't spam gets called spam? So what happens is it comes in, it's no longer in your inbox, it's over in your junk box.
Right.
So how do you discover that? Well, usually someone calls you up, emails you and says, how come you haven't responded to my email yet? Right. So you go and you look in the junk box and you, the user, are giving feedback to the system and you're moving it over into your inbox. That's a signal that says to the spam detector, that was a false positive. Mm-hmm. You called it spam, but it's not spam. Mm-hmm. And what's the other example? The other example is a false negative, something that is spam called not spam. That's the one that's is sometimes more frustrating because you start to get spam in your inbox. Now, how do you label that? How do you respond to the system? How do you help to train the system when a spam comes in that you didn't want there?
Well, I'm hoping that I'm going to be training the system by clicking on that message and saying this
Right.
isn't spam, for example, right?
That's right. So that's how you're giving feedback to the system. So the evaluation is done by you, the human. The spam comes in. It was called not spam, so it was a false negative, and you say yes, it is spam.
Mm-hmm.
Now, when you minimize the false positives, we call that precision. So
Mm-hmm.
precision means of all the things that I've called spam, what percentage did I get right? So if there's a bunch of things that weren't spam, but I called them spam, that's low precision.
Mm-hmm.
Recall is, did I get all of the spam?
Mm-hmm.
And so the real question is, which matters more to you? Do you prefer to have false positives, meaning spam in your inbox? Or do you prefer to have false negatives, meaning good mail in the junk box?
I don't want either.
But there's usually a trade-off between them. You can usually tune a system. Spam's actually gotten pretty good, so maybe it's a bad example. But usually you can tune a system
Yeah,
towards false positives or towards false negatives,
right.
but very rarely can you get them both. So
Yeah.
let's pull the thread here. Would you prefer to have false positives or would you prefer to have false negatives? Would you prefer to have spam in your inbox or not spam in your junk box?
I want the spam because it jumps out at me. I can just block it when I see it in
Okay.
my inbox because then my real
And
mail's there, right?
what's the danger of having not spam in the junk box?
Oh, I could click it and make a bad decision.
No,
Like,
but the danger of having not spam in the junk box
oh,
is that not spam could be an email from your boss.
oh,
That not
I see what
spam
you
could
mean.
be
Yeah,
something you have to react to,
yeah,
right?
yeah.
So
And I don't want to
it's
miss it.
really exactly. So it's really
Yeah,
important when you're thinking about an AI solution. I mean, we're talking about a fairly trivial and a pretty well solved solution. So
yeah,
I'm kind of stretching the analogy, but when talking about an AI solution, you really have to think about what kind of errors. You have to think about it from a product perspective. What kind of errors are you willing to accept?
yeah.
Would you prefer to accept the errors where you have good mail in the junk box, or would you prefer to have the errors where you have spam in your inbox?
Right.
Because you're probably going to have one. It's very rare that you can solve both. So you're probably going to
Hmm.
have one or the other.
Hmm.
Okay. So now we have chosen from a product perspective that it's probably better to have spam in the inbox if it's a work email. If it's a personal email, maybe it's better to have good mail in the junk box. So different context, you might choose to lean different ways. So the customer of the product, how you envision the product, that's going to have an impact on how you make that decision between false positives versus false negatives. But then you have to have a really good way for, number one, for the user to know that the system got it wrong, and two, for the user to have feedback to help the system get it right. Now,
Hmm.
why do I say that? Why do I say you have to have good techniques for the user to know when the system got it wrong? Well, this is statistics at scale, and statistics necessarily is not 100% correct.
Right.
It's guaranteed to be sometimes wrong, and since it's guaranteed to be sometimes wrong, it's got to be you have to think really hard about design. So we've been spending the last 3 months that I've been here at Cohesity thinking about the design of the AI that we build, so that the user can know or better know or have a better hint that maybe the solution that we provided, when is it sometimes wrong? And then when it is sometimes wrong, how can the user very easily give the feedback to the system? So
Yeah.
if you think, and I think it's really important that we think about it these ways, because if you think about it just as a panacea, which unfortunately it's being sold as, and it's not a panacea, but if you think about it as a magical panacea, well, then you don't think about it's ever getting it wrong. You just assume it won't get it wrong. So the way you design the user interface assumes that it won't get it wrong. And that means when it does get it wrong, the user doesn't know.
Mm.
To me, that's the worst case scenario. The worst case scenario is a system that tells you something with confidence and fluency and speaks like a human, but it's telling you the wrong thing,
Right.
right? So that's where I think there's some dangers in the trends of the last couple of years.
Yeah. Makes sense. Well, I think I wanted to talk a little bit more about security with you.
Sure.
So, what are some of the security dangers of AI, Craig?
Well, let's start where I think you should use AI. So I'm going to take it from probably a user perspective more than the usual view of security is about sort of cyber hackers coming into your system. I'm going to take it a little bit from poorly designed systems perspective.
Okay.
So when should you use AI? Well, you should use AI under two conditions. One, you can't write a program for it, because if you can write a program for it, don't use something statistical, just write a program for it.
Mm-hmm.
You can't write a direct program for it. And two, you either don't mind errors, which I'll explain. I'll give you an example of that in a minute, or it's easy to detect and correct errors, as we've already discussed. Now, what do I mean about don't mind errors? Well, we can think about tons of AI systems that make tons of errors, and we don't care, or at least the producers of the systems don't care. Ads is a great example. What percentage of ads have to be clicked on for companies to make hundreds of billions of dollars? I don't know the answer, but I bet it's not 80%. I bet it's 20 or 30%, right? Sure. So pick some, let's call it 40%. I don't know, there's X percent of the ads have to be clicked on in order for companies to make hundreds of billions of dollars. Well, that means those companies don't mind if the 60% get it wrong. They just don't mind.
Yeah.
Right? I mean, it would be better if they were right, but it's okay if they were wrong. Another example of recommendations, for example, being wrong is recommendations when you're shopping in an online shopping context. I buy a shirt, it recommends some shoes. It's okay if I don't like the shoes. I still bought the shirt, right? As long as I like this, as long as enough people like those recommendations enough of the time, that company is going to make hundreds of billions of dollars, right? So there's examples of not caring if it gets it wrong. Now let's talk about a problematic scenario where it's really hard for the user to detect. So you ask ChatGPT a question in lieu of search. This is a very big thing now that we want to just sort of use large language models, ask large language models a question. Not just ChatGPT, I shouldn't have singled them out, all of these large language models. You ask these large language models a question in lieu of doing the search, finding your 20 blue links, going to look at those 20 blue links.
Yep.
Okay. How do you know when it gives you back an answer, how do you know it got it right?
You might read it.
But you're asking a question, so presumably you don't actually know the answer yet. You don't know the answer yet, right? So you're asking it a question. It comes back with a fluent, like it's gotten really good at mimicking a human. It comes back fluent. It's got the right punctuation. It's got these really great sentences that make it sound like it's reasoned. You know, you apparently can ask it its chain of reasoning, which is also not true, but you can apparently ask it. It tells you how it thought through things. But a recent paper that I saw from Stanford said that 17 to 30% of the time, 17 to 30% of the sentences are wrong. Mm-hmm. They contain factual error. Well, the way you would detect that error is to read every one of the references. Well, and to detect and correct the error would be to read every one of the references. Well, that's a pretty bad user interface.
Right.
That means some percentage, because I will tell you, I've talked to lots of folks at big companies. They've reduced it to say 6% error or 8% error. They've gotten really good at lowering this error bar, and I'm very excited about that. By the way, I'm very bullish on this technology, right? Mm-hmm. I just think we need to think about the interface correctly. I'm very bullish on it. I mean, we're building analogous things here at Cohesity, but we're trying to do it with the right interface. So let's say we get it down to 5% or 4% error. Well, if you're asking it something that really matters, 4% error might be too small, and we don't really have a good interface, one, to detect when it's wrong, and two, to correct when it's wrong, you have to go read all of the documents, which defeats the purpose of asking that question. So we've been working really hard at Cohesity. I didn't mean to turn this into a Cohesity ad, but we've been in my career, I've been working really hard, and I've taken that here to Cohesity at trying to figure out what's the right interface for our Gaia product, which is a summarization product. Like you give it 10 documents and you ask for a summary or you ask it questions. What's the right interface that makes it as easy as possible for you to go back and forth with it so that you are sure that the answers you're getting are correct? And this is where I would really love to see the field move in terms of direction. The reason I brought this up in response to the security question is, what if I poison that information? Mm-hmm. What if I were to sneak documents into your data set? So here's the cyber aspect. Like I've now broken into your system and I've snuck documents into your data set. You can't detect it because the current user interfaces make it almost impossible to detect when the system's wrong or when the system's saying something. I mean, it's sort of a weird form of misinformation. What is misinformation? Getting the system to say things that aren't true that you want to plant in someone's head. You could also plant documents inside a system to help increase the likelihood that the things you want said that are not true would get said. So, but if you think about a different task, like let's say image search, and I search for cats, but someone put a bunch of dogs into the cats pile and I got some dogs back, that doesn't bother me because the ability to detect that error is very easy for a human. I see some cats, there's some dogs, I ignore the dogs, right? So that sort of data poisoning doesn't quite work in an image search context, but it does work in this generative AI context. So it's brought with it a whole set of almost like semantic security issues that haven't applied to earlier AI.
Yeah, I find that really interesting. I think about like medical diagnosis, for example. Data poisoning could be very
Sure.
catastrophic and even fatal if the wrong information is there. Or even financial analysis, you might make a decision on something and it's skewed. So I do find that to be a significant security danger for our listeners to be thinking about.
And if Theresa, if I could tell you the way we're thinking about it here, and I don't
Yeah.
mind sharing this publicly. Right now, when you interact with a large language model, you just get back the text, and then you get these small little references to the docs. I would prefer something like getting back the answer to the question and a listing of the docs that looks like search. Why? Because we've spent the last 20 years of our lives learning how to evaluate search results. So now I can have this listing and I can indicate these 5 went into that summary. These 6 might have gone into that summary, but we didn't think they were relevant enough. Now the human can go, oh, those 5, yes, those are relevant. I can look at I'm very good now in understanding relevant docs. So I'm glad that summarization is these 5. Oh, but you forgot that you missed this one. Let me add that one to the summarization, or let me take that one out of the summarization. And now we're giving the user the ability to help us evaluate the model in bringing value to the user.
Nice. Yeah.
So this is the kind of stuff we've been thinking about.
Yeah. Well, let's talk about that a little bit more. So where do you see us at Cohesity going with AI?
Oh, I think we can be doing, well, let's start with how much we've been doing. So, Sanjay, our CEO, likes to say that we're an AI-powered data security company, data security and management company, and that's 100% true. We think about it as 3 pillars of AI. The first pillar is the AI that we as a company have been doing to manage your data and secure your data. And there's whole bunches of AI there. We do it for classification of PII, detecting PII. We do it for ransomware detection. We do all sorts of anomaly detection for security breaches. So we use a whole bunch of AI techniques in this first pillar. We call that platform AI, where it's the things that we use to keep our customers' data safe, right, and secure. Then there's the second pillar, which is Insights AI, which currently we've released this Gaia product. And Gaia is a large language model product, a summarization product, and a question answering product. We discussed the ways in which we want to make sure that interface is working well with the customer. But there it's AI that we've built to help you gain insights into your data. We're thinking really hard about pillar 3, which we're calling ecosystem AI, which are what tools or services can we provide to our customers as a company, as an organization, to help their AI models be more successful. Remember, we manage massive amounts of their data. We understand how their data changes over time. We understand their different SaaS apps and on-premise apps and databases. We understand how we're already backing it up. And we do that, we take deltas every time there's a change. So we understand how that data changes over time. So we're thinking really hard about how can we take that information that we already have and surface it back to the customer. Say, for example, data discovery. I'm a model builder in a particular company, and I found a particular data set, but we could easily help that person understand that there's another data set that's semantically similar that other model builders have also used. If they used A, they also used B. And so we can help them discover data. We can help them with data governance. We can help them with a whole set of things that we're thinking through now that will help them build models for their company. So remember, pillar 2 is we're building models to gain insight into your data. Pillar 3, we're helping you build models to help you be successful in your business because you understand your business better than we do. So we already have a whole bunch of AI in pillar 1. Gaia and the things we're currently releasing, pillar 2, we're really excited about that. And then over the next while, pillar 3, how can we build an ecosystem to allow you to be more successful building AI in your own company?
Oh, I really like that. And, I've done a lot of using of the Gaia product already. We also have our AI bot that, will help look at ransomware. I couldn't agree more. There's a lot of exciting things already in place, and it's exciting to hear what's coming as well. So thank you for sharing that, Craig.
Sure.
So beyond that, I think we're right about at time. So Craig, thank you so much for joining me today. Appreciate it.
Thank you, Theresa. I had a great time.
Yeah. And thank you everyone for joining us for another episode of Spotlight on Security Tech Insights.